Over the years, you've solved all kinds of equations, from simple to complicated. Today we're going to look at a new kind of equation called a radical equation. A radical equation simply has a square root in it, as you see in this example right here. Now, let's take a look at the process for solving a radical equation. The objective is to get the square root alone on one side. So you want nothing but the square root on one side of the equal sign. Here, to do that, we add 7, and that gives us the square root of x equals 7. Now, the opposite of a square root is squaring. So, for example, if I have the square root of 25, that gives me 5. 5 squared brings me back to 25. So, to get rid of a square root, all I have to do is square it. So if I square this side and square that side, the squared and the square root cancel each other out. I'm left with x. 7 squared is 49. So x equals 49 is a possible solution. Notice I said it's a possible solution. When you solve these equations, sometimes you get bad solutions. It's the way it works, because you square things and things become positive. So, when you solve these equations, you always have to check your work. And you have to check it by plugging your answer into the original equation, just as I've done over here. So I had the square root of x minus 7 equals 0. I plugged in the 49. Square root of 49 is 7. 7 minus 7 is 0. 0 equals 0. It did work. And so therefore my solution is x equals 49. If you find a false solution, we call those extraneous solutions, you're forced to reject it. And we'll see one of those in just a few minutes. But before we do that, I'd like for you to pause the video here and try example 2. Example 2 is just like this. Well, how did you do? Did you get x equals 81? Did you remember to get the square root alone on one side of the equation and then square both sides? Did you remember to check to make sure that you didn't have an extraneous solution? Perfect. That's exactly what you want to do. Now, the next example, example 3, I want to take a look at it because it actually has a solution that is a bad solution, an extraneous solution. It's a reject. And let's take a look at it. I'll show you how that works. We have the square root of x plus 13 equals 0. It looks innocent enough. We subtract 13 from both sides and we get the square root of x equals negative 13. Now we square both sides, we get x equals 169 as a possible solution. But we have to check. We check by plugging it into the original equation. We got 169. We put that in the square root. The square root of 169 is 13. 13 plus 13 is 26. 26 equals 0? Well, that doesn't make any sense. That's a bunch of baloney. If you get a baloney answer, something that's just crazy and insane, it didn't work. You have an extraneous solution, and you have to reject the solution that didn't work. We typically cross it out and write reject under it. Because we don't have a solution that worked, we simply write no solution. Let's take a look at the next example. On example 4, they ask us to write a proof. Now, let's start by solving the equation before worrying about all these reasons. And if you have different colors at home right now, this is a great place to use some of them to help organize your work. We have 3 square roots of x minus 1 equals 6. And we want to get that square root alone so that we can solve the equation. I begin by adding 1 to both sides. That gives me 3 square roots of x equals 7. But notice that my square root is not alone yet. I still have the coefficient, the 3, out in front. It's 3 times the square root of x, and so I divide both sides of the equation by 3. That gives me the square root of x equals 7 over 3. Now that my square root is alone, I can go ahead and square both sides. Because remember, the opposite of a square root is squaring it. That leaves me x equals 49 over 9. Now let's write the reasons in for our proof. What's written here in red is what was given to us. That's what was printed on the page. Then, in green here, I added 1 to both sides. That's the addition property of equality. Next, I divided both sides by 3 here in blue. Dividing both sides, that's the division property of equality. Finally, in purple, I squared both sides of the equation, and when I square both sides, it's called the squaring property of equality. And I finished my proof with a QED. So that's how you can write a proof with a radical equation. Really, the only new thing here is the squaring property of equality. If you square both sides of an equation, it stays in balance. Let's take a look at another example. Here in example 6, we have something a little bit different. We have under our square root a 5x plus 9. We want to get the square root alone, and that includes everything that's under it. That whole thing comes as a package. So we'll begin by getting rid of this 12 that's on the outside. We'll subtract it from both sides. That gives us the square root of 5x plus 9 equals -2. Now that the square root is alone, I can square both sides, and the square root is now gone. I have 5x plus 9 equals 4. Now I just solved this simple equation, and I end up with x equals -1. Remember, x equals -1 is a possible solution. You must complete a check to make sure it's not a bad one. I plug that -1 into the original equation, and lo and behold, it doesn't work. Therefore, I'm going to have to reject x equals -1, and I have no solution. On example 7, we have something similar going on. We want to get the square root alone, and there's a 3x minus 6 under it, and that's okay. That comes as a package. We have this time a coefficient. The coefficient is 10. It's 10 times this radical. Well, the opposite of multiplication is division. And so what we'll do is divide both sides of the equation by 10. That gives me the square root of 3x minus 6 equals 6. Now that the square root is alone on one side, we square both sides. The square root and the squared cancel out. I have 3x minus 6 equals 36. I solve this basic equation, and I get x equals 14 as a possible solution. Now I have to write out my check to make sure it works. I plug x equals 14 into the original equation, and I find out that it does work. Therefore, x equals 14 is the solution to this equation. Example 9 is a little bit different. Here we have two square roots, one square root on each side of the equal sign. That's what you want to do. You want one of them on each side. Once you have one square root on each side, then you just square both sides. And the opposite of the square root is the square, and so they cancel each other out. That leaves us over here with 4x plus 1, and over here with x plus 10. Now I just solve this equation, subtract x's, subtract 1, divide by 3, and I get x equals 3. X equals 3 is a possible solution. Don't forget you have to check. You have to make sure you didn't get an extraneous solution. And so we take the 3, plug it into the original equation, and see if it works. By the way, it does. So if you have two square roots, get one on each side of the equal sign, and then square both sides. Now, I know what you're thinking. What if they're both on the same side? Well, that's exactly what example 10 is all about. Here we have the square root of 6x plus 9 minus the square root of 3x plus 10. We simply move this to the other side. We're adding it to the other side. And so what I have is the square root of 6x plus 9 equals the square root of 3x plus 10. Notice it was negative here, and when it moved over, it became positive. Now that I have 1 on each side, I square both sides of that equation. 6x plus 9 equals 3x plus 10. Now, solve the equation. We get x equals 1/3 as a possible solution. Don't forget to check. Plug it into the original equation. That means this one that was printed on the page. See if it works. It does work, and therefore x equals 1/3 is the solution to this equation. Here's what you need to remember. Always get the square root alone. You may have to add stuff to each side or divide stuff on each side. Get the square root alone first, and then square both sides. If you have two square roots, you want one on each side of the equal sign, and then you can square both sides. Don't forget to check, because sometimes these equations can produce extraneous solutions, or solutions that are actually rejects. It may be the case that you have no solution to your equation. This is everything you need to know about working with radical equations.